Hello everyone, welcome to Genique Education. So today we'll be discussing an important question regarding the equivalent circuit of the transformer. Okay, so first of all read the question carefully. A 5 kVA 50 Hz single phase transformer has a turns ratio. Turns ratio is not exactly like that, but this is the voltage ratio. Okay, but in this question they have mentioned that this is the not turns ratio, the simply ratio means here the ratio between the primary side voltage to the secondary side voltage. Okay, the data taken on the LV side, that is 200 volt side, at rated voltage, that means 200 volt, shows the open circuit wattage as 100 watt. Okay, so open circuit wattage means what is that wattage? What is that power consumed by the transformer at the open circuit condition? Tell me. That is the pure iron loss. That is pure iron loss. When neglecting the winding resistance, when you will neglect the winding resistance, then it means the power consumed by the winding resistance is 0. Then simply the power consumed by the transformer at open circuited condition is purely iron losses. Okay, the mutual inductance between the primary and the secondary windings is 2 Henry. You know, the mutual inductance, that means the mutual flux plays the role in order to induce an EMF in the secondary side, which is mutually coupled to the primary side. This is the principle of operation of the transformer. Transformer operates on the principle of mutual induction. So here the mutual inductance value is how much? 2 Henry. Okay, neglect the winding resistance and leakage reactance. Okay, what value will be the current taken by the transformer if no load test conducted on the HV side? Here first of all, in this question the data given are when the open circuit test is conducted on the LV side, that is 200 volt. But here they asked the data when the open circuit test is conducted on the high voltage side, which is 400 volt. Okay, are you getting my point? So how to proceed this type of question? First of all, tell me, after reading this question, definitely आपके माइंड में आ रहा हो कि ये कौन सा this question based upon which topic, which concept involved in this question? Tell me. Here purely you have to apply the equivalent circuit of the transformer. So in order to solve this question, we need to draw the equivalent circuit of the transformer and combiningly the testing of the transformer, and purely in this question open circuit test is involved. So you have to draw the equivalent circuit of the transformer for open circuited condition. Okay, basically we conduct the open circuit test on the LV side. Okay, but in this question they ask the data, that is the ammeter reading. What will be the current taken by the transformer? That means the ammeter reading when the test is conducted on the HV side. Rather it should be conducted on the LV side, but it is conducted on the HV side. So we have to find the ammeter reading. Are you getting my point? So what I told you, you have to draw the equivalent circuit of the transformer, equivalent open circuit test of the transformer when test is conducted on the LV side, first case. But we have to calculate, we have to find when the same test is conducted on the HV side. Are you getting my point? So let me write here. The solution is, so first of all tell me what is the transformer here. It is a single phase transformer. Okay, so when first case 1, केस 1 में क्या है, ओपन सर्किट टेस्ट on the LV side. So you know it should be conducted at the rated voltage. So यहाँ पे भी rated value क्या है, 200 volt. Similarly, the open circuit test wattage means that is the iron loss. That is the iron loss. So what is the iron loss in this case? W iron. Iron loss is how much? 100 watt. And again, the mutual inductance between the primary and the secondary side is how much? 2 Henry. Frequency of operation is how much? 50 Hertz. 50 Hertz. Correct? Now I have to draw the equivalence open circuited test with respect to the primary side, with respect to the first low voltage side. So this one is the equivalent circuit, and of course for open circuit test the load branch is absent, absolutely absent. Only the shunt branch would be present, and in that shunt branch, two branches will be there. One is iron, one is magnetizing component of current, which is, this is the magnetizing component of current, I mu. It is denoted by I mu. For, let's say, for the LV side, I am considering as I mu 1. This is the magnetizing current, okay, and this one is the loss component of current, which is denoted by IW, and let's say this is IW1, and this voltage is how much? Low voltage, rated voltage, that is low voltage rating is how much? 200 volt, okay, and in this case this is the mutual inductance, which is how much? 2 Henry. So can you tell me what is the mutual reactance? XM will be given by J2 FM. So tell me what is the value of J2 FM. I am directly writing here. The value is 628.31 ohm. Okay. So the value of mutual reactance is how much? 628.31. Okay. So how to find the value of IW? So you know, in this circuit the power loss is how much? 100 watt, which is nothing but the iron loss. And you know, the power consumed by the inductance is 0. So obviously the power consumed by the resistor is the entire iron loss. So you know, the iron loss, that is 200 watt, is given by how much? V1 into IW. So V1 into IW. So in this case, what is the value of V1? Tell me. 200 volt into IW. Okay. And in this case, I have considered IW1. So IW1 का value क्या होगा? 200. No, this one is 100. Iron loss is 100. So 100 by 200. So it will be 0.5 amp. 0.5 ampere. Okay. It will be 0.5 ampere. And from this circuit, tell me, from this circuit, I know the value of voltage across this inductor. I know the value of impedance of this inductor or the reactance of this inductor. Then I can easily find the value of I mu1, that is the magnetizing current. In the first case, that is the when open circuit test is conducted on the low voltage side. Are you getting my point? This is very simple question, but you have to apply the concept. First LV side का डेटा हम फाइंड करेंगे, देन HV साइड का डेटा फाइंड करेंगे, लेकिन HV साइड का डेटा फाइंड करने के लिए LV साइड का डेटा फाइंड करना जरूरी है. एंड दो इंपॉर्टेंट रिलेशन आपको पता होना चाहिए. क्या है वो रिलेशन, हम डिस्कस करेंगे I mu1 फाइंड करने के बाद. ओके, सो I mu1 क्या होगा? 200 वोल्ट. suppose the reference voltage is 0 degree. Reference voltage is 0 degree and the reactance is how much? 628.31 एंड इसका एंगल क्या होगा? 90 डिग्री. सो आई म्यू वन का वैल्यू क्या होगा? डेफिनेटली इन एन इंडक्टर, in an pure inductor, current lags behind the voltage by 90 degree. Okay, so it would be 0.3183 angle is minus 90 ampere. Minus 90 ampere. So what is the no load current or the excitation current? What is the no load current or the excitation current? So the sum of IMU1 and IW1 would be how much? The no load current or the excitation current. I denoted as I naught 1 because I naught is the excitation current or the no load current. Okay, so what would be the value of I naught 1? It would be the sum of these two components, and absolutely this is not your algebraic addition, this is your factor addition. ओके, सो वेक्टर एडिशन में यहां पे क्या होगा? एक सपोज द रेफरेंस इज 0 डिग्री. सपोज द रेफरेंस इज 0 डिग्री. वन इज द फेज डिफरेंस बिटवीन दिस टू वेक्टर इज हाउ मच? दिस टू वेक्टर इज हाउ मच? 90 डिग्री. सो यू हैव टू अप्लाई द पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन. ओके, और इंस्टेड ऑफ दैट सी ये क्या है? IW1, ये क्या है? I mu1, ये क्या होगा? जस्ट अ मिनट. दिस वन इज योर IW1 एंड यहां पे लैग कर रहा है करंट. करंट इज the magnetizing current is lagging behind the voltage by 90 degree. That's why this one is I mu1 and ये क्या हो जाएगा? I naught 1. So from this figure you can say that this is 90 degree. So यहाँ पे Pythagoras theorem apply होगा. I naught 1 will be it will be I mu1 square plus IW1 square. So इसका वैल्यू क्या होगा? 0.5 स्क्वायर प्लस 0.3183 स्क्वायर. लेकिन आपको क्या फाइंड करना है? यू हैव टू फाइंड द नो लोड करंट व्हेन ओपन सर्किट टेस्ट इज कंडक्टेड ऑन द HV साइड, नॉट इन द LV साइड. बट ये क्या है? दिस इज द ओपन सर्किट टेस्ट, सॉरी दिस इज द नो लोड करंट or open circuit current when no load test is conducted on the LV side. Okay, so how to find I naught 2? So how to find I naught 2? How to find I naught 2? What is I naught 2? I naught 2 is the open circuit current when no load test is conducted on the HV side. So यहां से आप बता सकते हैं कि I naught 2 का दोनों कंपोनेंट्स है. क्या है? I mu and IW. I mu क्या होता है? This is the magnetizing current and this is the loss component of current. So similarly, अगर HV साइड में ओपन सर्किट टेस्ट हम कंडक्ट करेंगे, वहीं पे भी आपको दोनों कंपोनेंट्स चाहिए. One is I mu, another is IW. Suppose the I mu and IW are I mu 2 and IW2 when the open circuit test is conducted on the HV side. So tell me I naught 2 का वैल्यू क्या होगा? I naught 2 का वैल्यू क्या होगा? I mu 2 square plus IW2 square. Are you getting my point? But now the challenge is to find the I mu 2 and IW2. So how to find I mu 2 and IW2? Here you have to know two important concepts or two important relations. The first one is whether the test is conducted on the LV side or in the HV side, the iron losses remain same because it is made up of same iron material, and again it is operating at same flux. It is operating at rated flux. Whether the test is conducted on the LV side or HV side, you know the flux density in the core is given by V1 by F. So flux density means this is the rated flux, phi rated. Suppose the transformer is operating at rated voltage and rated frequency, then you can say the transformer is operating at rated flux condition. It is operating at rated flux condition. So if you operate the transformer at rated flux condition, whether the test is conducted on the LV side or HV side, अगर LV साइड का रेटेड वोल्टेज क्या है 200 वोल्ट है, HV साइड का रेटेड वोल्टेज क्या है 400 वोल्ट है, अगर हम HV साइड मीनिंग 400 वोल्ट में अगर टेस्ट को ऑपरेट करेंगे, वहां पे भी क्या होगा, रेटेड फ्लक्स में ऑपरेट करेगा. देन दैट्स व्हाई the iron loss remains same because it is operating at the rated flux, same flux, or else you can say the same flux or rated flux. In this case it is operating at rated condition, that's why the flux remains the rated one. But the important condition is whether the test is conducted on the LV side or HV side. In both the cases it should if it is operating on the same flux condition, so the iron loss remains constant. So अब बताओ आयरन लॉस क्या था, पहला केस में 100 वाट था, यहां पे क्या होगा 100 वाट. सो पहले आई नॉट टू फाइंड करने के लिए हम आपको क्या बताए थे, यू नीड टू फाइंड द वैल्यू ऑफ Imu2 and Iw2. So what is Imu2 and Iw2? How to find this value? From the equivalent circuit. So again we have to draw the equivalent circuit of the transformer at equivalent circuit of the transformer when the open circuit test is conducted on the high voltage side. So this one is your 400 volt. This is the open circuit test condition, okay. And ये क्या है आपका Imu2, ये है Iw2, and this one is your I02, okay. So Iw2 कैसे मिलेगा, you know the iron loss is constant, that is the 100 watt. So tell me the expression for iron loss or open circuit. What is for this condition, for this equivalent circuit? It will be P naught is equal to 400 into Iw2. So P naught क्या है 100 है. So Iw2 क्या होगा, it will be 100 by 400 which is equals 0.25 ampere, okay, 0.25 ampere. Now how to find the value of Imu2? So in order to find the value of Imu2, what I have told you earlier कि Imu2 फाइंड करने के लिए आपको क्या अप्लाई करना होगा, MMF remains constant, that is flux is constant. Flux is constant in both the cases, whether the transformer is whether the open circuit test is conducted on the LV side or the HV side, it doesn't matter. But since in both the side it is operating on the rated voltage and rated frequency, so obviously in both the side it will be operating at rated flux condition. So rated flux meaning rated MMF, okay, rated MMF. So MMF remains constant. So I can write here N1 Imu1. MMF is given by number of turns into the current through the winding, or the excitation current. So N1 I mu1 is equal to N2 I mu2. Okay. So I mu2 का वैल्यू क्या होगा? It will be N1 by N2 into I mu1. So N1 by N2 you don't know. N1 by N2 you don't know. But N1 by N2 is proportional to the voltage ratio, that is the 200 by 400 into I mu1. So I mu1 का वैल्यू ऑलरेडी आपके पास है. I mu1 का वैल्यू क्या था? 0.3183. So I mu2 क्या होगा? Half of I mu1, which is equal to how much? Which is equal to 0.15915. 0.15915 ampere. I am directly writing here. Okay. Okay. Are you getting my point? So our prime objective is to get the no load current when the open circuit test is conducted on the HV side. So in order to get the no load current, I need to have two components of current. One is I mu2 and IW2. So I got the value of I mu2, IW2. Now apply the Pythagoras theorem, apply this relation, substitute the value of I mu2 and IW2 here. You will be getting, after substituting, you will be getting, I am directly writing here, it will be 0.296 ampere. It will be 0.296 ampere. Okay. So this question was based upon the equivalent circuit of the transformer, but along with this question you need to have applied two important relation or important concept, that is iron loss remains constant whether the open circuit test is conducted on the LV side or HV side, and second thing is MMF is constant or flux is constant. These two things you need to apply in this question. So hope all of you got this concept. Okay, and I will come with another important question in the next class. Okay, so thank you all of you for watching this video, and God bless you.